Hello everyone, and welcome back to our foundation engineering class. So we try to continue the class uh, with the chapter 4, special cases on foundation, shallow foundation. So this this video will cover the point 4, 5, and 6 of this chapter. In the previous video, we did this point where we have two soil layer and the upper layer was stronger and the bottom layer weaker. Okay, so the point number 4 was kind of very specific, because if there is a bottom layer that is weak, and the thickness of H, if you remember H in the previous video, was the thickness of the upper layer is very small, then you will have a lot of trouble. Yeah, but the second, this point 5, we have a stronger bottom layer. In that case, the stronger bottom layer will just increase the bearing capacity. So the effect of that bottom layer will not be negative in that case. That's why the point number 4 is very important. You have to be careful when you are designing the foundation. If you have this case where the bottom layer is weaker, okay? Yeah. But in this case, if you don't, if you have the effect, the influence of the stronger bottom layer, it will just increase the bearing capacity. So it is like kind of advantage. We have also the another situation where sometimes when you have clay, and people do like a trench and they put granular soil to enhance, to improve the bearing capacity of the foundation. Yeah, sometimes this happen. And this video we will try to cover these 2 points. Okay. First one, when you have a stronger bottom layer. The second one, also, it kind of like a soil, the ground improvement, improving the bearing capacity of soft clay using a granular trench. Okay. So this is what we are going to discuss today. So let's start with the bearing capacity of layered soil. Weaker soil underlaid by stronger soil. What will happen then? So before you watch this one, I really recommend you watch the previous video first. It will make everything easier for you. Yeah, it will be easier for you then to understand this one. Okay, so when we have foundation resting on weak soil layer, and under that weak soil layer we have a stronger one. Okay, in that case, the ratio, do you remember we talked about Q2 divided by Q1 last time? Okay, Q2 is the capacity kind of from the bottom layer, and 1 is the upper layer. So since the bottom layer is stronger than the upper one, so this ratio will be greater than 1, obviously. Okay, if you have already watched the previous video, you will understand what is this ratio. Okay, so illustration. So here we have, okay, first please understand how this figure is made. You can see here, just divide half of the footing is modeled here, is drawn here, left and right. So here, instead of doing uh, two two figures, it like combine two figure in one figure. Okay, watch this line in the middle, symmetric. Okay, this half is where we have the failure line, the slip surface, failure surface entering the bottom layer. Okay, this is the upper layer. H from here to here may be the upper layer, but the same soil here. But what is interesting for us is this one. And here is the stronger layer from here. This line is the border between the two soil layers. So as you can see, left one, the slip surface, the failure line is crossing the border. Okay, in that case, the bottom layer will contribute to the bearing capacity. And since the bottom layer is stronger, it will increase the capacity. Okay. On the other hand, you have this side where H, the upper layer, is thick enough so that the failure is confined only on the upper layer. Here, the bottom layer is at this level. Okay. So if you can hide just symmetry, okay, the other part is not drawn. For example, if you want to complete this one, it should be like something like this, symmetric. Okay, but the other half is not drawn here. Or if you want to complete this one, right one, it should be like this, something like this. Okay, so it kind of combination. So take it case by case. The left one is when the H, the thickness of the upper layer is not big enough to contain the failure. Okay, so the failure line, the failure surface is crossing the border between the two soil layers. In this precise case, the bottom layer will then will contribute to the bearing capacity. And then this ratio, Q2 divided by Q1, it's like a ratio of the capacity of this stronger layer divided by capacity of weaker layer. So it will be obviously greater than 1. But we will need this ratio also. In this case, you will see. So Q1 is this. In the previous video, please go back and check. It's the same equation, okay? And Q2 is this one. As you can see, Q1, you can see it using the information soil parameter of the upper layer. These are here, gamma 1, C1, phi 1, okay? You can see C1, you can see gamma 1 here, and NC and gamma are obtained from phi 1, okay? And Q2 is from the bottom layer. So since these are stronger, they are higher than this one, so the ratio, this divided by this, will be greater than 1. So if you remember in the previous videos, the previous one, we have some design chart where we used this ratio to estimate capacity. Okay, so already explained, if the depth ratio H bar B, H, you know already what is H. In this case, it is here, it's small h. In this case, it is here, it's larger h. If this ratio is small, then you will have this situation. The failure surface at ultimate load will pass through both layers. This will cross the border. Okay, so for this case now, for the large H bar B value, the failure will be confined here. Okay, only in the upper layer. It will not reach the bottom layer. Okay, so in such